Hey everyone! If you're a developer, you know that database performance can make or break your application. So today, we are diving deep into one of the most powerful tools in your arsenal, indexing. We're going to compare how three absolute giants, MySQL, PostgreSQL, and ClickHouse, tackle this. Because, let me tell you, their approaches are worlds apart.
It's the question that haunts us, right? It keeps developers up at night. You've built this amazing app, everything's working, but it's just slow. Well, more often than not, the real villain behind the scenes is a lack of proper indexing. But what even is an index?
Okay, let's make this super simple. Think about a phone book. Now imagine it wasn't sorted alphabetically. To find one person, you'd have to read every single name on every single page. That nightmare scenario is what your database calls a full table scan. And indexed is basically the alphabetical sorting. It's this neatly organized guide that lets the database skip all the noise and jump right to the data it needs. No more flipping through every page.
But, and this is a huge but, indexes are not free. There's no such thing as a free lunch in databases. This slide lays out the fundamental trade-off perfectly. On one hand, your reads, your select statements, become incredibly fast. That's the win. But on the other hand, your writes get slower. Every single time you insert or update data, the database has to do extra work to update not just the data, but all the indexes too. It's a constant balancing act.
So, let's talk about that speed boost. Just how fast are we talking? Well, most databases use a structure called a B-tree. Think of it like a super efficient search guide. On a table with, say, 1,000,000 rows, a good index might find your data in just 20 steps instead of 1,000,000. I mean, that's the kind of insane performance boost we're going for. So, how do our three databases handle this? This isn't just about slightly different features. No. We're talking about three completely different philosophies for how to organize and find data. Each one is purpose-built for a specific kind of job. And here's the roadmap. First up, you've got MySQL, the absolute workhorse for most web apps. Its core idea? The data is the index. Then you have PostgreSQL, the powerhouse for really complex apps. Its philosophy is all about having a specialized tool for every single job. And finally, there's ClickHouse, which is built for analytics and just completely rewrites the rules. Its whole game is about skipping data you don't need. Let's dig into each one.
First, let's talk about MySQL. The best way to think about it is like a single, perfectly organized bookshelf. Its whole approach is pragmatic, it's straightforward, and it's incredibly good at what it does, which is powering transactional web apps.
Now this is the most important thing to understand about MySQL, the clustered index. What this really means is that the data itself, the actual rows on the disk, are physically sorted in the order of the primary key. So in our bookshelf analogy, the books are literally arranged on the shelf by their ID number. This makes lookups by that primary key lightning fast because the index isn't just pointing to the data. The index is the data. There's no extra step.
So what happens when you search by something else, like a user's email? Well, that's where you get this secondary index hop. First, MySQL looks up the email in the secondary index, which is sorted by email. But that index doesn't have the full row. It just has the primary key. So then it has to take that primary key and do a second lookup in the main table to find the actual data. This also leads to a super important MySQL rule, the leftmost prefix rule. If you have an index on, say, last name and first name, your query has to use the columns from left to right. You can search for Smith, but you can't just search for John and expect the index to work. Okay, now let's switch gears to PostgreSQL. If MySQL is that organized bookshelf, Postgres is like a specialist toolkit, and it is jam-packed with all sorts of exotic tools for really complex data problems where a simple index just won't cut it. And just look at this toolkit. I mean, you have so many options beyond the standard B-tree. You've got GIN indexes that let you search inside complex data like JSON or arrays. You've got GIST for geospatial data. You can even create partial indexes that only cover, say, your active users to save a ton of space. Or expression indexes, which can index the result of a function, like making all your emails lowercase for case-insensitive searches. It's incredibly powerful. And this is exactly where that flexibility becomes a lifesaver. Imagine you're storing product details in a JSON column, and you want to find all products that are blue. As one developer put it, trying to do that in MySQL would be painful. But in PostgreSQL, you slap a GIN index on it, and it's blazingly fast. For modern apps that deal with this kind of messy, semi-structured data, this is an absolute game changer. All right, I need you to take everything we just talked about and just, for a moment, throw it out the window. Because ClickHouse is a completely different animal. It's not trying to find a needle in a haystack. It's more like a data detective whose only job is to figure out which giant haystacks it can completely ignore. So ClickHouse uses something called a sparse index. Instead of carefully mapping out every single row, this index only keeps track of the beginning of these huge blocks of data called granules. Its entire purpose is to look at a query and say, okay, you don't need to look in these million rows over here or those 10 million rows over there, just skip.
This slide right here gets to the heart of the philosophical shift. MySQL and Postgres are all about building these dense, detailed maps to find the exact row you need. ClickHouse does the opposite. It builds a very rough map designed to avoid reading data in the first place. When your queries are scanning billions of rows for analytics, this strategy of just skipping massive chunks of data is what makes it so unbelievably fast.
So if you remember only one thing about ClickHouse, let it be this. Your order by clause when you create a table is everything. It is the single most important performance decision you will ever make. It literally dictates how the data is physically sorted on the disk, and that in turn decides how well the sparse index can skip data for your queries. If you get this right, your analytics will absolutely fly.
Okay, so let's pull this all together. We've looked at 3 really different ways of thinking about indexing. So how in the world do you choose the right one for your project? Well, here's the final breakdown. For your standard web app or e-commerce store, MySQL's clustered index is simple, it's fast, and it's effective. Just make sure you master that leftmost prefix rule. If you're building something more complex with rich data types like JSON or geospatial info, you just can't beat the flexibility of PostgreSQL. But if you're doing any kind of real-time analytics on massive data sets, ClickHouse's and its skip-don't-scan philosophy is the hands-down winner.
And that really brings us to the final question you should be asking yourself. Every single index you add speeds up some of your reads, but it also slows down all of your writes. The real art of database design isn't just about adding more indexes. It's about finding that perfect balance. So take a hard look at your own systems and ask yourself, are your indexes a finely tuned tool, or have they become a burden?